Hello, it is Sunday, September the 18th, 2022, and the first thing to say is I'm quite excited. I'm quite excited because I'm actually making this recording directly from the Apple Mac and not via my Windows server, because I have a new way of getting through to my vintage computers, which is, all this detail is completely aside from the fact that what we're trying to do here is test the hard drive, the IBM 0665 hard drive. So without further ado, we'll start talking and boot the Chromco computer at the same time. So the plan today is to test the IBM 0665 hard drive. It's nominally a 44 megabyte MFM interface hard drive. It's a full height 5¼ inch hard drive, and it's really heavy, even by olden day standards. That's because it's a very solidly constructed drive. I hope you can hear the fact that it is spinning like a little kitten. So it's spinning very smoothly. I'll just finish the boot of the computer. Now, okay, the Chromco system has booted. We'll just do a few little housekeeping chores, which is that the clock stopped working at the end of 1999, so I've got to manually set it to today's date. Right, so we are looking at the disk, which we can see in the dev directory as D17 and we'll have a look at that disk right now. You can see it has got multiple partitions for this Chromco format, but the result is that if we were to add all of this up, you'll notice that we see we've got a total of 51, not 44 megabytes, because that's the space efficient way that the Chromco system works. So this is the partition table. We've got 733 cylinders and we've got 7 heads. The 8th head is, I believe, is servo, and so not available for data storage. We have already defined some alternate tracks here. So for example, we've said that cylinder 54 head 1 is mapping onto cylinder 90 head 0. So the alternate track table is stored at cylinder 90. I didn't actually format this drive, initialize this drive. I personally would have put it right at the end had I done it. Anyway, let's. What we're going to do is we're going to check the integrity of the drive. Read all of STD31. This will take a while, but we will chat whilst we are doing this. Now, the alternative tracks are stored at cylinder 90. We've got 14 alternate tracks. We've got 7 heads. So effectively tracks 90 and 91, or cylinders 90 and 91 are used for all the alternative tracks. There are 14 of them. We'll get to 54, let's see what happens. You see, in actual fact, cylinder 54.0 is clean. So I think when this drive was initialized and then the alternate track table was set, we may have been going from the defect label on the front of the disk, but in fact that's not required. Now, in order to explain further, drives of the day didn't have automatic defect management, so when you bought a drive you had to do your own defect management, and that's carried out by the operating system. So this is a 733 cylinder drive, and the idea would be that you'd possibly give a few of those cylinders up to defect management, and then your operating system would have to manually do that. And that's why on the head of this disk is not only the partition table saying where all of these partitions are, it's also saying where the alternate track table is living. But right now we have 0 errors, which is great. So we're going to get to 733. I think this is going to get a little bit boring, so I'm going to shut up now and we're going to watch the secret sauce at perhaps a faster speed. So we're finishing up the surface check. As you can see, there are only 3 surfaces so far that have any defects on them, and that's quite astonishing. I've owned this, oh, so 4. I've owned this disc since new, and by new I mean about 1980. I'm guessing something like 1985, 1986. So I've owned this disc for some considerable time. It's been in my possession and used actively in the 1980s. Since that time, it's now been retired, and certainly for the last 20 years it's been held in a climate control cave, and now it's time for it to move on. So I'm making this rather accurate test now to see what the condition of the drive is, and it's just stunning, We've got 4 surfaces. If you look at the disc label that's in one of the photographs, you'll see that this is about the same number of defects as was on the printed disc label when it was new. That's just how well made this drive is. I would say that of all the drives that I've used, I am a biggest fan of this drive. It's a very large and heavy drive, but it's superbly engineered. It's got its own servo sort of surface, and it's got 7 heads that can be used for data. I really think this is a superb drive. Anyway, that's it for now. As you can see, it's working, and I'm so excited to say that my new screen capture directly on my Apple Mac is now working, because I'm going via a Raspberry. This is a subject of a completely different video, but I'm able to access the vintage computer via internet, via a LAN-connected Raspberry Pi, and that's ever so satisfying. Anyway, we're going to shut the machine down now in the correct fashion. Then I'm going to power off the Chrome cone. Now I'm going to pull the power from the hard drive. You'll see it's shut down nicely. I'm going to wait a few seconds. We're going to power it on so you can hear the start up. Drive has started up beautifully. Okay, that's it, Dari. I hope you agree that this is one hell of a drive. Thanks for watching.